Okay, hello there guys. We are just going to look at how we are going to use PFTrack for a simple tracking this time. So the version of PFTrack I'm using is 2011.3. So let's get started. I'll bring in my footage. So the sample of the footage is this. So the main things you have to look for in a footage is what kind of camera motion is there first, and then the kind of object motion which exists. So as we can see in the footage, there is camera motion which can be observed in the background, like this bullock cart thing which we have here. So this is moving, and so is the landscape in the BG. You can see the trees and everything over here which are moving. So first thing is we need to set up our camera and do the camera track, solve for the camera. Then once we are done with it, then we can start with the object, that is our dog's head in this case. So let's get started with it. First let me open up PFTrack. Okay, so by default this is your PFTrack and already a project is open here. So let me just go ahead, create a new project for us. So I'll just hit create, and the thing is over here we have organized it in different batches, so I'll be creating a different one. This was related to batch 4, so sorry, this is batch 1, so I'm creating a batch 1 folder for this. And the footage we just looked at was the short number 1041.5 part 1, so I'll give that in 1041.5 part 1. So that's taken in. The main thing is in PFTrack 2011 you have to set the frame rate right from the beginning, so I've set it over here at 25 frames per second. Then we have the camera preset. Camera preset is basically the film back of the camera which has already been provided. By default it's constant throughout the project, and you will find it in the short details section which we give to you. And right now I've already set a camera preset over here called project, which is the MatchMove project which we are doing right now. So let me just set it to auto for now, so that I can actually show you how to create one if you don't have one set. So once I have set these things, I'll go hit confirm. So my new project is created. If I go back to my project panel, you can see the new project which is created. It's stored at this path and it's 25 frames per second, and the camera preset is set to auto for now. I'll come back to my default panel. Now the main thing is I had to go bring in the footage, so let me just navigate to the footage directory. So projects, MatchMove, I have my footages. This is from batch 1 and the footage is here. So the main thing is this is not a course to show you the capabilities and what all PFTrack can do, but this is just a demo of what we need from you, especially only for this project. So right now we have this footage here. I can select it, right click on it, move around, see the footage. I can click and drag it into the bin or into the project view. So I'm just dragging it into the bin. If you want to know the names of the different UI elements, you can go to the Pixel Farm website where they have hosted free tutorials on PF Match It, which has a similar interface to PFTrack. So there you can get to know all the user elements and also more functionalities related to PFTrack. So once I've loaded this in, I'll bring it to my project panel, and as soon as I do that, my media bin and file browser have both been closed. To open them up, I can click them back again, or I can come back to my camera view. So this is what I have. So first off, right now this is already set to project. So if you had to set your own, all you have to do is for camera preset, go to custom, whatever film back values we have given you, just put those in, and then given the right pixel aspect ratio for this project the entire way, this is the film back we'll be using. So over here it's 12.44 and over here 22.09, so that's constant throughout. But right now I'm just going to use the project preset, which is going to give it to me automatically. Then we have the frame rate 25 frames per second. Now let me just go through and finish the tracking of this. So right now what we want to do is first solve for the camera. In PFTrack 2011 camera, whatever solve we had to do, we can either use feature tracks, or also known as user tracks, or we can use auto tracks. But for the camera movement which we have here, it just looks like a basic rotation, and most of the footages that we will provide to you will have only basic rotation and nothing else. So for that reason, the only tracks we need are auto tracks, not user tracks, because user tracks don't give you the option for only rotation in camera. So first thing, let me go bring in an auto track. I want to see what all will be tracked by PFTrack automatically if I just hit auto track over here. So if I just turn on my preview, you can see that not only the background but even the head and everything is selected or is going to be tracked, which is not really necessary because we only need the background truck to be tracked in. So I'll just go into mask. I only want this region to be masked so that I can go ahead easily track it in. So I'll go take in my roto. I'll drag a rough mat around it. So once that is done, I can just go through. So here it changed, so I can hold control on my keyboard and move the mat wherever I require it, and change the shape also. So now I have this mat moving across, and let me just finish this up. Okay, so my basic mat is done and I can start doing the tracking for this, but right now the mask is inverted, meaning it's masked inside, so this is what will not be tracked, and whatever is like actual image color is what will be tracked. So I want the pink region outside rather than in, so I'll go ahead, hit invert on the over here the option. So now I need to only track this one out. I go back to my parameters view and turn on preview, and now we can see that only this is what is being tracked. And now the main thing is we want to track this, but we really don't have a lot of info. And if I just zoom in, and for zooming in it's middle mouse, right or left, and for panning it's right mouse, and just move pan it around however you want. Now if I observe this top portion of the mat, you can see that the hairs are coming in and PFTrack is trying to track the hair, which is going to give us really bad results. But whereas in PFTrack we have this beautiful option where we don't want it to search just to get tracks, we want it to give us optical flow. Basically what optical flow determines is if points are moving in random directions rather than in a particular way they are supposed to give the proper parallax, they will be removed by PFTrack automatically rather than we having to do it ourselves. And next, another thing, most of the footages we provide will have backgrounds blurred because the foreground subject is what is in focus. So we don't really need the track to track all the noise, because if I zoom in you can see there's a lot of noise in the footage, and we don't want PFTrack to consider the noise to be features. We want it to consider these big blotches of details to be the features. So first thing, I'll go ahead and tell image feature scale as large, so that PFTrack is considering larger features for track. And next one more is the image proxy which I wanted to use will be, let's say, half, so that it's considering half resolution images, so thus reducing a lot of blur, and then it will track it much better. So this is only for those footages where the background is blurred. If not, you can just go ahead and use it however you wish. Then another thing is it may give us very less number of tracks. So let's say I want a higher number of tracks, so in that case I'll go ahead, increase a candidate number. Wherever these like input boxes are there, you can just click on them with your left mouse button and drag to increase the number. And also target number, I'll just increase it. And because my user feature track is feature scale is set to large, and also my image proxy is half, I'm not able to see extra tracks right now. So instead of I give it to normal one, you can see the number of tracks have increased. So if I give it to a smaller number and increase these values, you can see the number of tracks have increased, but right now really not required. So I'll just put it back to large features, and also set it to half proxy mode, so it gives me this better track. And pretty much that's it. I'll go ahead, hit track, and if you see the tutorials, basically what it basically does is once you hit track, it's going to track each one of these features on its own rather than we having to go ahead and track it ourselves. But before we do anything, one very important thing is, as I told you, we need rotation only in the camera. So right now the consistency is set to free camera. That means the camera can dolly in and out or can pan around or do anything, but right now we only need the camera to roll, or we want it to tilt. So thus we'll go, instead of free camera, we set it to rotation only, so the camera can only rotate and nothing else, which is going to give us much better tracks. And basically that's it. We can go hit auto track, or we can shift click on it so it background processes it. So right now I'll just go ahead, shift click on it, so it does the entire thing in the background. So when it's happening in the background, as you can see here, it's showing this green progress bar over here in the node graph. So this basically means that the track is happening, and it's better to do it in the background process if you have several footages to work at the same time, because even though this node is doing something, I can bring in other nodes and I can work on them at the same time without having to sacrifice my speed of work or anything as such, because the graphic card is doing this work and I can use my processor to do this. And right now I don't really need this node, so I'll just go ahead, delete it. Let me go ahead and just pause the video till this is done and get back to you. Okay, so we are back again, and as you can see, the green progress bar is finished. So I can double click on this auto track and it's back again over here. Now if I go ahead and just play the video once, you can see that the tracks are moving accordingly. But one thing I failed to mention before is this green bar that you can see over here on the time slider. This is your cached frames. So right now the frames are not completely cached in, so the playback will be very slow. So instead we can go ahead, click this C icon over here, which is going to cache everything into memory. So whatever playback you're going to do in the future is going to be faster. But remember, this is not related to what is being displayed. This is just so that it keeps whatever is supposed to be displayed in memory. It doesn't store auto tracks or anything as such. So if you want to store such thing, these are the nodes which store them in. So right now, as you can see, the track is done. There are several nodes which are giving good results, but as soon as the hairs and things come in, they go off. And there are other tracks which are tracking things like the hair over here. It's really not going to matter to us because there are enough tracks in here which are giving us good enough detail, and we don't really need to worry about the tracks which are not giving us detail. So let me finish that up. I'll go ahead, create a edit camera node right now. So this node is basically going to tell what is my camera focal length, is the position, and all those things. And also one thing I would like to mention is you don't actually have to use this node all the time. It's just something we pipelined into our work for this project. So right now the main thing is, whenever we provide you the footages, we also give you the camera details. So this will be the kind of camera details that will be provided to you. So the shot that I'm working on is the first shot which was provided to us. So right now we already know that our frame count is 164. The kind of character we are working with, it's the dog. And then the focal length, this is very important. And then we have the camera height. What is the height of the camera from the grid plane? Basically our grid plane is going to be the ground. It may not be the ground in all the cases, like it might be let's say a table or anything as such. So the height reference is very important. And then the focus distance. This focus distance is actually the distance between the object and our camera. So after that we have the tilt angle. Tilt angle is your camera's angle, like whether if it's looking up or is it looking down. So basically a positive tilt angle means it's looking up, and a negative one means it's looking down. So please do not put it into your camera Z rotation, because this is your actual camera X rotation. And shutter we really do not require. It basically means if we have a larger angle shutter, we will have more motion blur, and lesser we'll have lesser. So that really doesn't come into the digital environment, so we don't have to worry about it. So once we have this info, we can get back to working on PFTrack. So as we saw, we don't need any values in X, because that is basically means our camera is on the side. So just to let you see it much clearly, I'll go put on 2 horizontal views. So here you can see our camera just moved on to the side from here. This is basically keyframed it, so my camera is actually moving from here to there. We don't really want it to happen in the future, so I'll tell you how to get rid of it later on. So I'll just go set all the properties here. So we saw that the camera height is supposed to be 60 centimeters, so I'll go plug in 60 and my camera goes up. And one thing people are seeing getting confused with is that the grid in PFTrack is set to 1 meter, and we are plugging in 30 units here, which means the camera has gone up 30 meters. But the point is, units are generic within the software, so doesn't matter what you put in, just make sure you keep the things consistent. Like if you're plugging in 30 over here, make sure you maintain the same thing everywhere. Like this is actually 30 centimeters, so make sure everything is 30 or whatever is in centimeters throughout, and do not put meters in one place and centimeters in one place, because that is what will cause the problem. So I'm going to zero out all the values. So we also need tilt on the camera, so I'm going to go ahead and set tilt angle, and the tilt angle we saw was 8 degrees. So I'll go ahead to x-axis, put in -8, because that is what is going to tilt my camera 8 degrees above. So if I zoom in, you can see that my camera is tilted up. My camera is tilted up 8 degrees, and it is set properly in the center of the grid. and that is almost done. But the thing is, it's moving right now, and this is a problem which I've seen a lot, so that's the reason I put it in. So the only thing we had to do is just go back to the frame where it's actually keyed and hit remove keyframe, and that basically removes it. Or one more thing you can do is, if you do not know where the keyframe is placed, since you can't see any keyframes here, go into your curve editor, choose the values which you have actually keyed, and you can see the curves for them. You can select the points which you do not require, and you can hit delete over here, which basically resets the camera too. Also we have rotation keyframes here, so I'm going to even reset those. So several ways to reset it, all of them work the same way. So couple of manual, couple automatic, so just make sure you know the options. Okay, so other than that, our camera attributes are set in. Now I can go ahead and start solving the camera. A couple of key points to remember when solving the camera, a couple of nuances and annoying ones. So let's go ahead and put in a camera solver. So as soon as we bring in a camera solver, you can see focal length parameter is over here, which we did not set in our edit cam. So let's go back to edit cam. The focal length is supposed to be 27, not 26.6. to 27, enter. We plug that in, and you can immediately see the grids moved and the focal length is changed for the cam. The focal length is basically given by the angle of the camera. So if I give a large focal length, like let's say 200, you can see the camera is very, very small and narrow. Whereas if I give a smaller one, like 27 right now, it gives me a wider one. If I give a smaller one, like let's say 5, it gives me a really wide one. So make sure you put in the right focal length, because this basically means your camera plane is different. So put it back to 27. I come back to my camera solver. Right now it's not taken in because the nodes do not feed off each other once they are created. So I can either come to camera solver, tell it's a known value, I can plug it in over here 27, and I'm done, or I can just go ahead, delete it. I can put in a new camera solver, and that automatically brings in that focal length value which was created in the edit cam after the node was created. So this is very important to remember, because once you have set some values in the node and you create another node connected to it, all the values which are currently set are taken in as initial values, and once you change them in the previous node, they are not taken in into the next node like we have in new Core Fusion. So that's a very important thing to remember. Okay, and now that we have set our focal length and all the parameters, let's go ahead do this one last thing, because we know that our camera is only rotating and not moving. So under translation, I'll go ahead set it to none, because I don't need any translation motion. And also under rotation, we can set it to normal, so that it's going to rotate but nothing else. And we can lock the roll so that the camera is not going to tilt. My font settings have rendered out all the L's and I's out of the view, so that might be a problem. This is actually lock roll. Then under rotation, I don't want any jerking rotation movement, so I'll go set it to low smooth, so that the camera motion is automatically smoothed out. Now once I set these parameters, I can just go ahead and tell solve. So it's going to solve it out. Since it's not going to take a long time, I'll just go hit it. So you can see it's really fast, because it's just a rolling motion and things are solved in. So now if I go ahead and play, you can see it's solved, and all the extraneous movements which we had in the trackers are all marked in red, and other things are taken in, and this is pretty much a done solve and nothing else to be done here. But one thing you can see here is the camera is back to the starting position which we had, which is not really what we wanted, because we already set things in the edit camera. So whenever you're doing a camera solver, it's not really necessary to use the edit camera, as I had said before. So the focal length is already here, so you can set it. So the only thing right now we have to do is make sure the camera is in the right position. So I can go ahead, set an orient scene node to this. So my orient scene is going to be here. So this orient scene is basically going to change the position of your camera and nothing else. So I can go ahead, plug in the values for this. So basically it's the same thing which we did before. So 30 on this, nothing on this, minus 8-degree tilt over here, and nothing on Y and nothing on Z. And I did it in the first frame, so because of which it's not keyframed anywhere else, and I have the values directly in. And the best thing is you can see that the camera is tracked, the camera is moving in the 3D view, and the point cloud is created. And a few people have a problem with seeing the point cloud inside the camera, but just remember the camera is actually here. This is just a display. You can plus this grid plus or minus to set the camera size, so it doesn't really matter how far these points actually are, so forget about that. Next thing is, once you have done the orient scene, as you can realize, this edit camera is not really required. but I'll come back to it and tell you why it's important. So orient scene is done and our camera setup is almost done. So next thing is we need to start tracking the geometry, and basically for that we need a geometry tracker. So I'll go ahead, put in a geometry track. I'll show you a basic geometry track which you can do, and then do the same thing with user track so you can see the difference. So first, as soon as you're loaded in your footage and you put in your geometry track, let's go bring in the actual head mesh. So let me go back into Maya for this. So in Maya, let me open up the actual base mesh which will be provided to you. So base meshes, okay, as you can see, this is the base mesh which will be provided to you. But the thing to remember is you can't actually use this base mesh all the time, since looking at the footage over here, you can see that the skin over here is drooping a bit more, the jaw is not out, and there is a lot of fur on the character which is not at all there in this. So this is actually going to be the part of the skin rather than the fur, and the fur is actually supposed to be sticking out of this. So using this directly for the track is not a best idea. Whereas as we already know, the client is going to be tracking only the lower part of the jaw, so we don't really need the lower part of the jaw as per such. It's going to be animated and only the upper part of the jaw is required. So I'll go ahead and delete the entire lower part of the jaw, which is not at all required for us, only for track purposes. So I'll select all these faces, delete them. So the lower part of the jaw is done, and anyway the inner part of the jaw is not seen and it will cause problems when we are tracking, so I'll go ahead even get rid of that. So that is gone. And next, basically looking at it, this is a very neat mesh to use, nothing else much with it, but main thing is the position of the pivot point does not need to change. So please do not edit the mesh in any way as to change this, like for example scaling it up and down, or for example going ahead selecting only the vertices and scaling them up or down, because that is basically keeping the pivot point at the same place, only moving the mesh, and also moving the vertices completely because the pivot point has still stayed the same but the object has moved. We do not want any such things. We want the mesh kept as similar as possible. We just want the locator in the end, so please do not change any of those attributes. You can delete or add in any extra meshes that you want, like for example I can go ahead close the eye portion, I can go ahead delete the additional region which are there which is not really required. So I can go ahead delete this, because let's say the dog is blinking its eye, and this mesh is what is supposed to form the region of the eyelid, so I can get rid of it, and thus completely avoiding the additional work of having to go ahead and solve the eye blink. So right now once this is done, I'll export this out. So let me go ahead, and since the character's name is Alfred, I'll just go ahead and name it as such. So Alfred, and just so that it's organized, I'll give it a version 1. And I don't want to keep any groups as of now. I'll tell you why. I'll just turn on groups for now. I'll tell you why it's best to keep it off in a minute. So export this out. I'll come back to my PFTrack, and over here with my geometry track selected, I'll go ahead click load. So once I'm here, I'll go to my MatchMove base mesh, and over here I'll select my dog Alfred version 1, open it up, and as you can see here, whatever groups I just turned on, that is the reason PFTrack is asking me this question, whether if I want to use this group as a deformable geometry. PFTrack has a wonderful option of tracking deformable objects. Right now we do not want to track any deformable objects, so this is a no answer which we have to give here, which can directly be avoided when exporting meshes out of Maya. Okay, so next, the main thing to remember is Maya's coordinate system, the software which we are using, which is Maya. The coordinate system within it is actually right-handed and not left-handed, and as you can see in this 3D view right now, the entire mesh looks like as if it's flipped inside out. This is because PFTrack by default comes with a left-handed objects coordinate system. So let me switch it back to right-handed. So immediately, as you can see, the object is facing the right direction. So basically we are set to go. The other main option I want you to remember is this moving object. Please make sure this is turned on, because we want the camera, we do not want the camera to move so that it's a static object. We want the object to move, because the object is what is actually moving in our footage. So once we have set this and the right handed, we can just check whether if our focal length is right over here. And remember that if the focal length is wrong in the beginning when you created the geometry node, then it's totally a waste of doing any kind of track, because this value cannot be changed again once it is plugged in. So you'll have to delete the node and recreate a geometry track. So pretty much all the track you do is like utterly of no use. So please make sure you do not do that. Okay, so next thing is we just need to start tracking it. So first thing, I want it in the center of the view, so I'll click my view button, so my mesh is in the center, but I really can't see the shading on this right now, so I'll go put it to shaded hidden line, so I can see the wireframe mesh. Next thing, just Maya like navigation, alt left click, rotate around, middle click, zoom in, right click, pan around. So I'll just go ahead, try to set up the mesh as close to the head that we have here. So remember, to scale the object you just need to zoom in and out, and to rotate you have the basic controls. So you have any perspective changes, like something in the begin, something in the front is of a different size and something in the back is of a different size, that basically means that you have a problem with perspective. So right now, as you can see, I'm trying to set it up, but it's really hard to line things up. Like, okay, if I line the nose up, it's harder to line the things in the front up. So when we have such a problem, we have this option over here. So there was an error in the recording, so let's get back to this. So by default, the Maya like navigation that we get for to move objects around is because of our transform mode, which is set to fly. So if I change it instead to this other option pin, I can go choose different vertices on the mesh, set it to the exact location that I want it on. So I can go ahead, choose the eye to be here and the other eye over here. So that sets things up. And the jaw has become smaller, so I can go drag that out, so I can make sure the jaw is lining up. You can add in as many number of pins as you want, and if you have added a pin which is not required, I can go on top of it. Once it's turned blue, I can hit delete on the keyboard to get rid of it. So I can just zoom into a full viewer, the shortcut for it, which is Alt F. I can set it up perfectly along the mesh. By the way, the same control is available in PFTrack 5 or older versions also. So geometry track is there, but just a couple of more options in the latest version, but you can do most of these things even there. Okay, so once my geometry is set, all I need to do is start tracking it. So one major thing to understand is let's say you are trying to track it, try not to track throughout and try to adjust all the keyframes, or try to create too many keyframes. Try to put in keyframes only at positions where the object actually changes its motion, like whatever is the current motion. If it's about to change, put a keyframe in there, and that's more than sufficient. So if I move ahead, as you can see from here, from the starting frame 2850 to, if I go to let's say 2860, the motion is quite constant, and only over here at this frame, which is 2861, where the object is going to start changing direction. So 2861 is the frame where I want a keyframe, so that here to here the motion is quite constant and nothing much. So I want those places to be the ones which have a keyframe. So let me just go ahead, turn on my geometry, start tracking it. The only thing to look for when you're tracking is make sure the key positions, like whatever you can see specific, stay the same. Like, okay, I'm at 2861, I'll hit stop, so that'll stop my track. And here if I see my track is good, but it's not really exact. So why exactly am I telling that? If I zoom in, you can see the wireframe here. If I move across, you can see that it slips. It's not holding on to the actual object as such. So one thing which we can do right now is add in a couple of helper objects which can help us to maintain the mesh pinned to the exact position. Like the pins which I've just put in, the mesh will have automatically pins created which will pin it to that position no matter what happens to it. So looking at this, I know, okay, the nose is something which I really want to choose, because that is something which will have a lot of motion on it. and something at the back of the head which is away from the nose, so something like the forehead, because that will give me a good enough parallax so that the object motion can be easily calculated in 3D. And also some other points on the mesh which are like off plane, so this might form a single plane, so I'll take a point on the sides, so that will give me a perfect track. So what I need to do is, before geometry track, I'll go ahead, choose my orient scene node and put in a user track. So once I've connected this in, I'll put it down to geometry track. As I told you before, whatever changes we make to geometry node before it is connected to other things will be lost, but user tracks is something which will be taken in, so that's the reason I'm creating it later on. So once I've taken in a user track, I'll just zoom in. As I can see here, the dog has a blotchy mark on the nose, so I'm going to track that one in. So I'll just go create, click over here, so it's going to create my tracker. And since it's just a simple user feature track which I'm creating and it's not really a lot, I'm just going to make sure that it's large enough to accommodate a larger pattern so that noise is not considered. So the way you can put in the size of your track is basically see how much noise is there in the footage. If there is no noise, then of course the feature track can be as small as you can just get a proper feature in there. If there is a lot of noise, I suggest having bigger user track size so that noise will cancel each other, the noise will cancel itself out and you get a proper track. And also I just want to turn on deformation, the rotation, scale and skew, so that the track stays in the same place. I set the window update to above threshold and I just set it as default, so whatever tracks I create from now on will have the same defaults. I'll just go ahead, hit track forwards, and if you see this, I only need to see this window to see whether the track is good. Looking at this, I can see the track just slipped, so I'll just hit escape on my keyboard. I'll go back here, the point where it slipped, so here it's perfect at this frame. I go forward 2 frames, 3 frames, 4 frames, here it's already constant. So the frame where it's still slipping, I go to the last frame of it, I move the track to the exact position that it's supposed to be at, and over here I have polish, but right now the frame has slipped only for 3, so I'll go polish range, set it to 3 and hit polish on, and it goes ahead, polishes it out so that the tracker doesn't move away. So from here I need to track once more because that's where the motion was, so going ahead and tracking it from there. As you can see, it's not fitting in perfectly, but it's really not much of a problem because it is giving us a good track. Just so we can see it properly over here, I can turn on center view so the track is exactly in the center. I'll turn off show search and path so I can exactly see the track and go ahead, track it. So when I'm looking at this, what I want is the entire image moving but nothing in the center going anywhere. I want it just rotating, skewing, moving around, but nothing in the center move. Anything in the feature could move but not the center. It's supposed to be like the pivot point of an object which is rotating or moving. Okay, so this user track is done, so let's do something else. I can see that this patch on the nose is a really good thing to take up, so I'll go ahead, choose a corner of it. I'll go reduce the size because I really have a good pattern over here which cannot be missed. I'm keeping it on this black region over here, and I've set it at the last frame instead of a starting one. So I can just go reduce my search region. Remember that the search region, the larger it is, the better the track, but also it's going to take a long time, and the more chances you have about the track flipping here and there. So try to have the smallest size you can without losing the track. So I've set it up and I go track backwards, and you can see here it's sticking quite nicely, and because I had already set defaults on the previous track, the deformation values and the above threshold are already set in and I don't have to worry about it again. And you can see it's sticking in quite nicely. I don't have to worry about that too. All I'm trying to do is get points which show some parallax. As you can see, this point is sticking in, but related to this track, the original track, the 0001 is actually moving around. So that has given us a certain amount of parallax which the geometry track is going to use. So basically we need to add in a couple of track points just like this. So let me just pause the video, add in a couple of track points and then get back. Okay, so now as you can see, I've finished up with 4 user tracks and each one at a different depth. So when the character is moving, each one moves a bit differently and related to each other, so that's going to give me a better result. And also I've added in a couple of tracks with a bit of jerk in them, like as you can see up here in this track, it doesn't sit perfectly, so I've added that in. So let's go back to geometry track. Once you have added any user tracks, you can see under the helper section you have those tracks visible. You can go just turn them on, and now going back to the same frame which we had, if you don't really want to see the tracks, you can just go turn off show helpers. The tracks are still used because they are active, we are just not seeing them right now. So I can just go ahead, track it, and as you can see, even though there is a lot of motion blur, the object sticks perfectly with the mesh, especially in the places where you have placed trackers, whereas it has lost a lot of volume on the sides. So when doing this, the main thing, as I've already told you, is to remember to put in keyframes wherever there is a sudden change in motion. So easiest way to know where there is a sudden change in motion is actually your user track. Just go to your user track, select any one of them. Let me just show selected, and now as you can see here, in the beginning the track is moving up. So over here in the beginning the track moves up, and then there is a sudden change in direction, it starts moving down, and then somewhere over here it again starts moving to the side, bottom, onto the side, and all such things. So anytime there is a sudden change in direction, make sure there is a keyframe over there. So that's the most important thing. So I can come back to my geometry track. Anytime there is a sudden change, you'll see whether if the mesh is matching in perfectly. Like if I look at this right now, in the beginning the eyes look okay, the nose looks okay, but when it comes downwards, I can see the nose has slipped, it's not matching up anymore. So all I need to do is make sure I go back to the previous region where it actually started to move off from. So here I can see that at 2862 it's actually really good. So all I need to do is add in some kind of a motion into the object to insert a keyframe. Also there is a curve editor where you can select translate and just tell insert to insert keyframe, but I don't know why it never works, it doesn't create a keyframe. So the method we use is just take your pin, go ahead, choose the mesh, move it a little bit off to the side and back, and if you move back you can see there's a keyframe created over there. So all we need to do is make sure the keyframe matches up perfectly. So I go back forward where the nose has slipped a lot, I'll just select this, move it to the right place. I can see that this eye and this eye have slipped off to the side, so I can rotate that in, push that up a bit, and since I just reduced a bit of volume, I can also increase it up a little bit. So once that is done, if I see between these keyframes, I can see the object motion is suddenly very jerky between these two keyframes, the last two. So to observe that, let's go just to transform, let's turn off X and Y and just see for Z right now. As you can see, the keyframe where I just added in the actual motion, the Z value is actually similar as whatever it was before, whereas the other keyframes in between have a change in Z. This is definitely something which is supposed to be avoided, which is change in Z axis or any axis, sudden change. If it's not visible in the image, please do not have it in your graph. So the main reason for this is the client is going to be adding motion blur onto the object. So if there is any kind of a sudden change at all, the object is suddenly going to get blurred, and that really looks awkward, and the shot will be rejected if there is a sudden change as such when it's not required. So like for example, we had shots where characters blink their eyes and suddenly the mesh goes back, whereas in the footage when we see the Playblast, it looks absolutely okay, but in reality the object is moving back and forth from the camera, which causes a lot of motion blur. So anytime the character blinks its eye, the character is totally out of focus, so we don't want such a thing. So right now we have added in this sudden change in Z depth. As you can see, the object is moving back and forth too fast. I can go turn on my 3D view also. I'll just go to the top view. If I go back and forth, you can see the object is moving back and forth towards and away from camera. We do not want such a thing, so I'll go between the two keyframes and I hit refine. It tries to go ahead, flatten this out. So now as you can see, it's not that bad. So it tried to set it up properly and it's done. So now let's go ahead and finish up with the track. So the main thing is always make sure you look over here so that there's nothing changing on the surface. Like for example, the computer does not understand that this is actually a 3D object that it is tracking. It just thinks that it is pixels. So by default, when it is tracking, it does things as such, where the object is moving too much in Z. Like by default, all our units are in centimeters right now. So if you can observe, the bottom unit over here is 49 and the top unit over here is 51. So the object from the beginning to end right now has moved actually 2 centimeters. So that's really not a lot, so we can go ahead with it. Not at all a big problem, but let's say it just moved 10 centimeters instead of so much, then it will definitely be a big problem. And here, as you can see, there is a lot of Z motion which is happening, but it's not really a problem because it is a time when the object is actually moving, so the motion blur is going to blend in very nicely, so that's not going to cause a problem. So let's go ahead and completely finish the track throughout, and I'll be back. Okay, now just wanted to show you a kind of problem which you might encounter when doing a track. Like as you can see, when moving from this keyframe forwards, the object suddenly changes scale, which is very apparent here at the nose. When I go back and forth, the object is totally matched up with the entire face, and when I go forwards, it's slipping and it's moving backwards. So if I go back in Z, you can see that the mesh is actually moving back and forth. This is not something which we need. We want as flat a thing as possible. Right now the movement is just around 1.5 centimeters, but it's still going to cause problems. So what I would do is go to the point where it's actually stops moving and it's quite consistent. So once I have reached that point, I'll go ahead and set my pins once more. So setting up the eyes. Once I set up the points in the foreground, I choose something in the background and pull it out, so it basically increases the size of the object, and as you can see in the Z depth, it automatically matched up perfectly. So just make sure you put in the right match it up as close to the original head as possible, and sometimes do remember that the mesh that you have is actually the skin and not the fur part, so it might not match up exactly. So do try to look for the details which are quite close to the skin, like whatever I'm trying to match up are actually the bony parts, because there is not a lot of fur cover on them, and when you touch a dog on the nose, it's actually something which you can feel and there is no fur covering it. So that's what the mesh actually has inside it, so that's what I'm trying to track in. So once I have something set up which looks good and I have some good level of Z depth over here too, I go back to the previous frame and I hit refine. Usually it works out really well, it gives us a really good refine, but sometimes it does give us a very bad result. Like right now it just gave us a good result. It flattened it out and it made sure the mesh is sticking in. As soon as I go off this keyframe, you can see how small the mesh was. So once I set it up, I can track it forwards. So just keep observing the track which it's doing, see if it's moving anywhere. Make sure you put in a keyframe over there whenever it's moving, and pretty much solve the whole shot and you should be done. But also remember, this is something which works out for things which are easy. This is not a method which you can use for difficult shots which have a lot of motion blur. So we'll come back to a method in Maya which we'll be using to do difficult shots, which is going to be a lot helpful. No matter what kind of a shot you have, you can finish it in that method. So let me go ahead, finish up this track, show you how to finalize it, and then move over to Maya. So I just finished up with the track, so let's just observe this. I'll go ahead, play the footage by centering the view so it does not move ahead over here. So back and forward, as you can see, I have the head and I have a 3D textured head over here, just the textured option over here, and you can see that it's matching up quite well with the kind of motion we have here. So just make sure there is nothing slipping, there is no sudden movement in Z, and over here I also have the curve open for Z. As you can see, it really looks a lot jagged and really weird, but the point is the curve is moving only from a minimum value of 0.485 so to 49.5, so it's only a matter of 1.5 centimeters, so it really doesn't matter a lot, and it doesn't really move a lot suddenly. It only moves a lot when there is a sudden rotation, like you can see these two peaks over here, and these small regions are really so small that it's in millimeters and you really can't make out and thus absolutely no problem. So basically once you have this, you're done. You can export it out to Maya. So let's just do that now. To export whatever you are done back in the tree view, we need to put in an export node. So over here I'll put in an export node. In the export node, just choose the footage you are putting in. So this is the only footage I have in this pipeline, so this is the only footage I'm exporting out. You can have several other footages, so let's say I have another one, and all I need to do is put it into the export node, and I can export 2-3 things. So I can maintain several different tracks on the same page rather than a single one. So I can just plug it into the plus, and I have 2 different footages into the export node. Most of the options which have plus over here can accept more than one input, and they do the same operation over and over again. So once I have an input, I can choose whatever I want. Once it's chosen, just make sure you set the proper file format here. By a lot of trial and error, we have found that Maya output over here does not actually work. When we save the file for Maya, when we open it up over there, it absolutely is a total waste of time. It does nothing. So better option is save it out as FBX, and once you open it in Maya, we can actually get started up. So the location where you are going to export it out is given over here, so I can just browse it out. So let me just go back, create a new folder for batch 1, and here I'll just give the same name as the actual footage that we have. So the footage is 1041.5, so I'll put that in, save it out, and hit export scene, and it gets exported. It showed me export succeeded, so that's done. The only other thing I would require is a start and end frame, because most of the time the PFTrack takes in the image frame sequences, and we have tried the actual option of going in here and setting the in and out point, but it doesn't really work and causes a lot of crashing. So we leave it as it is, and we just need this in Maya. So it's 2850 3013. So let's go back into Maya and open up our FBX. So going back into Maya, I'll save out this file. I don't really need to save this one because this is our original head. So file, new, do not save. If you're importing your scene, please make sure that when you go into the new, you set in the option box that you're actually working with. You're working with 25 frames per second, because the entire project is 25 frames per second. Do not forget this. And then you can also set your start and end right here, which is up to you. I'll just go ahead, open back to my Maya folder. Here we have batch 1, and this is the FBX file I just exported. By default, when the mesh and the camera come in, they are exactly at the center of the grid. Please do not think it's a crash. Just move on the time slider and they snap back to the position they are supposed to be in. By default, PFTrack, because you have set the options, camera is pointing in the negative Z direction. It's exactly on the axis, and also the camera animation has come in, but we are not able to see it right now. I can open up the graph editor, hit A on the keyboard, and you can see that there is camera animation right now, and it starts at the same frame that we saw in PFTrack. So I'll go ahead to 2850 and 3013. So putting that in, I can see that my entire time is set in, and you can see the camera motion is actually come in, and the camera is actually moving in. You also have this interest point node, which is going to tell you what exactly the camera is looking at. So that one has come in, and also our point cloud is here. So right now we have this mesh which is moving exactly, and basically that's all we need. So the only last thing which will be required is a locator which has all the motion of this baked onto it. So let's just create that one last thing. I'll just go ahead, create, and choose a locator. Because the locator size is too small and cannot be seen in the Playblast, we are going to increase the local scale of the locator, not the actual scale of it. We do not want these changed. So local scale, I'll let's say set it to 5, so it's a really large one. I'll go ahead, select the mesh because it has all the transform values in it. Select my locator and go ahead to constraints. I'll go give a parent constraint. Make sure I reset it, maintain offset is off, add it. So now my locator is constrained to the mesh, and it moves exactly the way the mesh does. So once I set this up, you can see that translate and rotates have incoming connections in them. I can go select the locator into my edit menu, keys, and bake simulation option box. make sure your times is set for start to end. I'll just go reset it. The default values work best. Hit bake. It takes a second. It bakes all the keys onto the locator. Now I can go back to the outliner. Under the locator, the parent constraint can be deleted. All the values are baked into the locator. You have the scene node with all the mesh and everything. You can rename this as in the PDF which is provided, and basically your scene is done. The only thing to be concerned of is make sure none of the additional elements or extraneous nodes exist. So basically what that means is go into your Windows render editors, hypershade. By default PFTrack adds in a different material or FBX adds in a different material when objects come in. So please just remove these materials and apply default Lambert material onto your object. So just waiting for my hypershade to open up. Okay, so my hypershade has opened up, and as you can see it has created a fog material. I'll just go ahead, delete this material, and by default the mesh gets this green material applied, which is a point cloud thing. So I'll just go Lambert, middle click, drag on it, so that's applied. Next, back to the camera node. Most of the times the camera node will have the image plane created just because because of the Playblast which you have created. So we don't really need that, so we can get rid of it and rename all the nodes which you already have here and save out the Maya file, and pretty much you are done. Now okay, so basically that's it. So last thing I want to show you is how you would actually create a Playblast for this. So let's go to panels, perspective. I'll use the camera node for this, and once this is set up, let me go ahead, choose the image plane. I'll go back to my footages folder. So MatchMove footages, I have my batch 1. So this is the batch footage we just worked with. I'll choose this image, open it up. By default only a single image comes in, so it does not play. I go to my attribute editor. Over here use image sequence, because the frame rate starts from 2850, it is automatically set in. And also Maya likes having a dot or a period right in front of the numbering sequence. If you have an underscore or anything as such, it gives you errors. So please make sure you have dots, and all the image sequences we sent to you already have the dots, so please do not change them. So we have this. And next thing we want is the FBX file which comes in has a strangulated mesh. We do not want this strangulation, so you can go into your edit mesh, and over here you have, okay, sorry, under the mesh you have the quadrangulate option. You can hit that and it basically quadrangulates your mesh, so you don't have as much. The other way of doing the same thing is, if you want to do it faster, shift right click on the mesh, you have quadrangulate, finish that up. And then also we want to see the wireframe of the mesh, so I'll go turn on wireframe mode or hit 4 on the keyboard. Right now I can't really see the back side of the mesh because this is getting cut off. So let me just go ahead, select my image plane. I'll go increase the depth. Most of the times the mesh does cut in, so I'll go increase the depth. By default what would happen is the mesh would not be seen, but the image is seen, and you can increase this, and suddenly after a while the mesh starts appearing through it. So by default you do not want such a thing to happen when you're taking a Playblast, like the mesh going through the image plane. So please make sure, like as you can see here, if I increase this value, you can see the mesh is coming through the image plane. So please make sure you have a large depth value so that the mesh never goes behind it. And also I'll select this, go under display, polygon, turn on backface culling, so whatever is facing behind is not seen. So basically this is what I need in my Playblast. I can select the mesh so that it's highlighted. This is a dark background, so I want it lighter, so I select it. If it's a lighter color character and I want it to be darker, I can deselect it. So once it's selected, I just go ahead, choose Playblast. But before that I want to make sure my entire view is seen, like maybe the points are going off frame or the mesh is going off frame. I want to be able to see that the motion is right. So I'll go turn on my resolution gate, and that is done. I can see my camera node. You can also go ahead, display, heads up display, turn on your focal length so we can make sure the focal length is right, and also other elements like the frames per second and all the other scene attributes which you can turn on. And then once you have this done, go into Playblast. You can set it to either AVI or IFF. By default, Maya, even though you are set it to 25 frames per second, by chance renders it out at 24 frames per second, so you'd have to re-encode it. Please make sure all your Playblasts are 25 frames per second even after render. So once I've set it up, by default we use this resolution at our end, but make sure you do not give any resolution lesser than 960, which has been mentioned in the guidelines. So once this is done, we render this out, and basically our Playblast is done once we select it. So basically that's the entire overview of the MatchMove tutorial. Hopefully you have understood it. Any queries, please call me up since you already have my number, and also I'll be creating a few more tutorials on a couple of more advanced topics, and also creating a complete MatchMove right here in Maya rather than having to do it in PFTrack. So good luck. Hopefully we will see more number of footages from your side. Thank you.